Hi guys, welcome. So today we're gonna be doing February for March 2012 paper 1 for physics. So I'll be focusing on question 9, which is your electrical circuit. So in this question they say learners use Ohm's law to determine which one of two resistors. So you've got resistor A and resistor B. So they want to know which one has got the highest or the greatest resistance. They say for each resistor, they measure the current through the resistor for different potential difference across its end. The graph below shows the results obtained in their investigation. So here's what we're gonna do. So firstly, we know that resistance and current, they are inversely proportional. They are inversely proportional. So meaning when the other one increases, the other one decreases. So they are inversely proportional. So you see here at this point right here, point A, current is higher. And then if the resistance is high, R is high, then current is low at this point. Because the resistance, you see the highest resistance is that one, A. The lowest resistance, lowest R, means highest current. Highest current. Remember, current is opposite to resistance. So if you go back to Ohm's law, R is equals to V over I. Right? R is equals to V over I. So if you want to make it simple, look at this. If you say I is equals to V over R, to make it simple, this is how the easiest way to solve it. So remember, I is divided by 1. Do you see that I and V, they are directly proportional? When I increases, V increases. Right? And then R is not direct. Do you see that I and V, they are direct? They are on the same line. And then I and R, they are inversely proportional. So meaning when the other one increases, the other one decreases. Okay, so let's go to the question. They say the learners are supplied with the following apparatus: 6-volt battery, voltmeter. Then you need to know the symbols. So this is the battery. So you can have something like this. So this is the battery. The voltmeter, you just draw a circle and V inside. Then ammeter, you just draw a circle with A inside. Then rheostat, rheostat, guys, it's like a potentiometer. There is something that we call a potentiometer. Rheostat, it's a variable resistor. Basically, it's a variable resistor. So it's a resistor that you can adjust to get various readings. So the symbol is like this. It's a resistor, the normal resistor. This one is a changeable, like it's the one that you can vary. You can change it. Can change its resistance. It's not a fixed resistor. The one that you can't change it. So you just put this sign right here to make it a changeable. Then there's a resistor A and B. So the normal resistor, you just do this. There's a resistor A and B. So this is a normal resistor. It's fixed. You see, doesn't have that arrow. This arrow means it's a variable resistor or a rheostat. They say conducting wires. Obviously, a wire is a line. So they want you to draw this. They say draw a circuit to show how the learners must use the above apparatus to obtain each of the graphs shown above. Okay. So we have to draw. We have to draw this. So remember, we're gonna draw a series circuit. So you've got a battery. So you've got a battery, then you can write 6 volts there. And then you've got what? A rheostat. You've got a rheostat, you just draw the line there. And then you've got what? You've got a resistor. whether it's a resistor A or B. They didn't say if they are connected in parallel or series, so you're just gonna throw one resistor. So you just say R, then this one you just say rheostat. You can write rheostat there. Then this one you write resistor. Then here you write rheostat. You can just write rheostat there. Rheostat. Then is there anything? No. So remember, okay, so if I write resistor, let me write it here, resistor. Then there's nothing that is connected again. Remember, here's what we're gonna do. They gave you the ammeter. Ammeter, you connect it in series with the circuit. Ammeter, series. Ammeter, you write series. Ammeter, you connect it excuse me. Ammeter, you connect it in series. And then the voltmeter, you connect it in parallel with the resistor, because you want to measure the voltage across the resistor. You cannot measure the voltage through the resistor, but you can only measure a current through that resistor. But if you want to measure the voltage, you measure it across the resistor. So this is a series circuit, and that's how you do the first one. So we're gonna move to the next question. We're gonna move to the next question. We're gonna move to the next question. Okay, so let's move to the next question. So the second one, 9.1.2, they say write down one variable that must be kept constant. So we go back to Ohm's law. So Ohm's law, remember in Ohm's law, the potential difference in a conductor, right? You know that the potential difference in a conductor and the current through the conductor, they are directly proportional when the temperature is constant. Remember, they said it's Ohm's law. They gave you the, let me highlight it. They told you that they are using Ohm's law. So in Ohm's law, the temperature is kept constant when the potential difference in the current through the conductor changes. So the temperature is the one that is kept constant. So you can write temperature. Temperature is kept constant. Then they say which one of A or B has the highest resistance. So I told you already, highest resistance between which one, A or B. So they want to know which one has got the highest resistance. So let me show you. The one with the highest resistance, you see, the one with the highest resistance, is so let's go back to this question. The lower the resistance, I told you. So let's remove this. So as you can see, the current is higher at which point? So if you go to this graph, you see the current is high. Then here, let's say 0, 0. So I gave you the relationship between current and the resistance. 3, 4, 5. So here current is 5 amps at this point, the maximum. So at this point, current is high and then resistance is low. So at this point, high current I is greater than R. So current is greater and then resistance is low. Then at this point, current is lower, you see, Then this is your resistors. This is your resistor. So this resistor is lower. This one is higher. Why? Because R is higher, because the current there at that point is lower than the maximum. Yeah, you have got 2 amps there. Then obviously the resistance will be higher. Okay, so your answer there is B. The resistance is higher at B because they don't want the reason, but give you an explanation for the answer, okay? Because the current at point B is lower than the current at point B, or lower than the current at point A. Then you can go on and explain this and say, so it's 9.1.3. 9.1.3 can say, because the greater the current, the lower the resistance. Or the other way around. I is inversely proportional to R. So when current increases, resistance decreases. When current increases, resistance decreases. Yeah. Or I can use formulas. You can say R, remember R is equals to V over I. So if we go to the graph, let's say RA, the ratio, remember this is a ratio. So RA, if you go to the graph and then use Ohm's law, so you're gonna find RA is equals to VA over IA. Let's just compare them. You're gonna see the ratio is lower, and then VB over IB. So I'll go to this graph. Look at this. So we're gonna take the values. So you're gonna take current. Let's do the, you see there, let's say 1, 2, 3, 4, 5. So at this point, let's say it's 5. And then at this point, it's 2. So for B, VB, I'll just take 5. VB is equals to 5. Then IB is equals to, I'll just take 2.5 amps, then volts. And then VA, I'll take 4. Then IA, I'll take 5 amps. So you're gonna see what's gonna happen. VA is equals to 4 over 5. And then VB is equals to, just showing you how to calculate these things. And then 5 over 2.5. 5 over 2.5. So if you go to your calculator, and do this, you're gonna say 4 over 5. So we're going to compare the ratios. 4 divided by 5. Then let's go to this 0.8 ohms. So I'm just comparing the resistors. 0.8 ohms. Then we go to the other one. It's 5 over 2.5. You see, RB is 2. So the resistance RB is greater. You see, I just showed you. So this answers our first question. So you see what I was explaining, the relationship. So this one, it's 2 ohms. So do you see that? It shows you the relationship. Look at this. Here the current is higher. The higher the current, the lower the resistance. Lower R. I'm just showing you the relationship. Then here the resistance is 2.5, is lower than that other one. The lower the resistance, the lower the current, the higher the resistance. You see, the higher the resistance. Then this tells you that if you go back to Ohm's law, R is equal to V over I. What does this mean? It means these two. It means these two are directly proportional. As you can see, they are direct. And then these two are inversely proportional. You see? Because look at this. V is lower there. V is higher there. Meaning it gives you the higher resistance. You see? So if we go to the calculator and say, maybe let's have 5, we change the voltage to 5, then we divide it by 5, the same current. You see, you're gonna get the greater resistance. Then same thing is gonna happen with the higher. The higher you go with the voltage and keep the current constant, the more resistance you're gonna get. See, that's the relationship. Okay, then do we have any other question? Yes. So let's do this question quickly. So let's solve this question quickly. So this one, I'll solve it on the next episode, 9.2. 9.2, you're gonna solve it on the next episode.